Good morning, everybody. This is Codeforces round 666. Hopefully we do well today. We have company.
Understood, sir.
And let's begin. Solutions will be at the end of the video, and it probably won't be too interesting to watch because I'll be mostly competing rather than sharing my thought process. I'll be doing my work on paper as well. We have an array of n integers. The full thing, the length minus 1, length minus 2. Yeah, okay. So are we going to do the full thing, the first n minus 1, then the last n minus 1? Yeah, okay. So this is like Euclidean or whatever. So if we want like 5 times x to be equal to 4 times y plus 7, or I guess this is 4 times x minus 1. Then this would be, I guess let's do it with variables, so ax equals b times x minus 1 plus c. I guess we're not trying to find x, right? We're trying to find a and b. Yeah. So a times the length plus b times the length minus 1 is equal to c. How do you do these? Yeah, linear Diophantine. I guess we just need to do extended Euclidean. It's kind of annoying. there a better way of doing this? I don't think so. Okay, how do you do extended Euclidean again? Oh, we can just do, yeah, so we can do length minus length minus 1. That's equal to 1. We can scale both of them by c. C times L plus or minus c times L minus 1 is equal to c. So if we have a bunch of positions, we do, yeah, okay. All right, so they give us n in the array. Entire array first. Now we print the whole thing. Yeah, okay. So if it's just one long, we just do that. Exactly 3 times, okay. All right, otherwise we do 1 to n. So now we do, yeah, negative val times L, okay. Negative 8i times n. Okay, and then sys out the last one, which will be a at n minus 1 times long of n minus 1. Yeah, okay. right. Not bad. One to 4. That's kind of weird. Plus a space here. So -4, -12, -8, -16. -4, -12, -8, -16. Then +3, so that'll be, yeah, that'll work. That also works. That also works. Then we had 12 to the last one. Yeah, that seems to work. Okay, so let's try this. So 1, 7, 1 to 1, 0, 1 to 1, 0, 1 to 1, -7. Oh, no.
Problem A. Wrong answer test answer.
Really? What do you mean? What do you mean by that? Make all operations 0. I thought it was right. Why is it wrong? A at 4 must be 0. Oh. That should be N. He's playing a game with his friend HL. There are N piles of stones. The ith pile has this many stones. These two people will alternate turns, with this person going first. In each turn, a player chooses a non-empty pile, removes a single stone from it. However, one cannot choose a pile that has been chosen in the previous turn. The player who cannot choose a pile in his turn loses. The game ends, assuming both players play optimally, given the starting configuration of T games to determine the winner of each game. Is this hard? Huh, I don't know. T goes first, and then they alternate. So if you have one pile, then T wins. If you have two piles that differ by at most one. Well, yeah, okay. So if you have one pile that has over half the stones, over half or exactly half? It's got to be over half of them. If one has greater than half, then T can take that pile and get one parity, or take a different pile. Oh, I see, but maybe not. Well, he can always take the pile. If it has over half, you always take it. Then you win. If no pile has over half the stones, then it's just the parity of the total number of stones. Why is that? If you're gonna lose, you always just take from the biggest one each turn. Yeah. I think so, at least, yeah. True. Okay. So let's code it up since it should be pretty quick. Int n equals this, array a equals this, I assume. And sum equals 0. Sort this array. So now, if sum plus sum is less than, if a at n minus 1 plus a at n minus 1 is less than sum, this out t, or greater than sum. Yeah, if you have over half, then you're gonna win. Otherwise, if sum mod 2 is equal to 0, this out HL, otherwise this out T. I think that's fine though. So I'm not really too worried. Found a game called Monster Invaders. Similar to every other RPG, you involve killing monsters and bosses with guns. For the sake of simplicity, we only consider 2 different types of monsters and 3 different types of guns. The 2 different types of monsters are normal monsters with 1 HP, boss with 2. Three different types of guns. Our pistol deals 1 damage and our reloading time. A laser deals 1 damage to all monsters in the current level. It has this much reloading time. AWP instantly kills any monster with this reloading time. Guns are initially not loaded. You can only reload 1 at a time. Levels in the game is an array where the eye stage has this many normal monsters and 1 boss. Man, there's way too much bold in this problem. It's like, anyway, you cannot use the pistol or this to shoot the boss before killing these normal monsters. Huh. Okay. If this person damages the boss but does not kill it immediately, he is forced to move out of the current level to an arbitrary adjacent level. The only adjacent level of 1 is 2. Yeah, okay. So you have like a bunch of levels. If you hurt the boss but don't kill it, you have to leave the level. Then you can come back. Each move between adjacent levels managed by portals with D teleportation time. Okay. He starts at level 1. The objective of the game is to kill all bosses in all levels. Minimum time to finish the game, assuming... Does arbitrary means he chooses what it is, or is random? Boss has 2 hit points. So, I guess what are your choices? Does this have solves yet? You can kill... No. Huh. It's odd. You can kill... Well, what's the score distribution of these problems? Looks like it gets hard quick. Yeah, this kind of scoreboard is usually indicative that problem D or E is what people are going after. No one's solving C. Are there good LGMs and stuff playing this round? Who's this guy? He's an LGM. Not for long at that rate if he's getting 82nd place. Yeah. Huh. So either this is really time consuming, or it's really hard, or it's just there are other ones that are easier, more attractive maybe. Let's read this. He's a fat and greedy boy who is always hungry. After a while of searching for food to satisfy his never-ending hunger, he finds M&M candies in a L by L grid. He wants to steal a rectangle of M&Ms. I'm going to get one of each color. Got it. How many rectangles are there? Yes, standings isn't the interesting tab, that's problems. Okay, well, if these wind up being the only two problems, then this is looking good for me, because I had low penalty points on those, and although A was slow, I did B pretty fast. So, I think that's not the end of the world. Plus 63, yeah, not bad. It's kind of boring, right? It's only a 2-problem set. Yeah, I don't know. Well, the difference between, well, I guess it's only 10 places, yeah. So let's solve C. C is gonna matter. Or something's gonna matter. We just need one other problem, really. So what's the goal here? We want to kill all the monsters. You can either kill, like, what's the benefit of using the pistol? You could kill a bunch of things with the pistol. And then you could use the, like, AWG. So that's one way of clearing a floor. And then you just go directly to the next floor. But didn't they say you could, like, move between adjacent levels whenever you want? Yeah, you can also choose to move to an adjacent level at any time. So they have to be adjacent, though. Yeah, okay, so you can either use a bunch of these things and then do the AWG. What is the use of this pistol? Oh, I guess you could do the pistol for everything, so you could do a bunch of pistol shots. And then a second pistol shot. Or the alternative would be a laser shot to everyone, and then a pistol shot afterwards. Those are the only ways of killing people. The issue is you'll have to come back for these bottom two things. So they might be suboptimal. Here are 3 reload times. What is this third thing? Oh, the time between levels? Yeah, okay. Alright, so it seems like if we, like, black box each of these levels, then you're gonna cross each one either 1 or 3 times. Why 1 or 3? because you damage the boss like twice or once. You might as well go into the next room if it's all the same. Because it's not just a DP. BI can be equal to 0, yeah, okay. Yeah, why is this not just a DP? Why does this not have solves, guys? This is very suspicious. I don't like it. Can we not just do a DP where the state is like where we currently are? DP at the position and then need to go back one. And then we have, like, there are a couple things we might want to do. If we do all pistols in the AWG, yeah, well, why does this not work? I'm just gonna try coding it and see. So what costs do we need? Static, long, R1, R2, R3, and then also static, long, room travel time. And rooms equals this, R1 equals this, R2 equals this. All right, so we've got each of these things, and then we might as well read in the time between, or the number of enemies. I guess it would make more sense to have like a free go back, right, and just pay for it earlier. Yeah, okay. So if DP at position free go back, like -1. Okay, so if, well, what else? Base cases. So if the position is equal to the number of rooms, and return 0. Assuming we've cleared the rest of them. Yeah, okay. So now if free go back, else if, well, the rest just, no. So if we can go back for free, then we have 3 things. So we've got we also have pistol, 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 and then pistol, 2 travels, and a pistol. Okay, and then we also have the laser. Yeah, okay. Those are the 3 transitions. Yeah, okay. So now we'll have some best. Long best equals long 118. Turn DP at position, free go back equals best. Okay, so we have a bunch of pistol shots in the AWG. What's the cost of this? Best equals math.min of best and R1 times n enemies at this room. Are there AI enemies or AI in total? AI normal monsters, okay. As many normal monsters plus R3 plus go at position plus 1. We do not get to go back for free. I guess plus D, right? Yeah. Plus travel time. So we kill all of the normal enemies. Then we kill the boss. Then we go to the next one. And we keep going from the next one. Okay. Yep, that's one option. What's the next option? So this is plus R1. This is plus, well, we get the going back for free, right? So we don't have to pay the extra. So then, what's the third one? We use the laser, and then the pistol. So this laser is weapon 2, then the pistol is cheaper. So then we use the laser for everyone. We get the 2x travel time for free. Then we use the pistol. Then we have to travel the next one. We finish the next one. Okay. Then this one's going to be pretty similar, I think. So use the pistol a bunch, then the AWG. Yeah, so it's still, we have to kill all the enemies. Oh wait, this is a laser, right? So we only have to pay the laser once. Yeah. So now we don't get the 2 times travel time for free, but we kill a bunch of things with the pistol. Plus 2 times travel time. So we have to pay the travel time twice to go to the next room and come back. And then we shoot him with a pistol. Then we have to go to the next room. Now we finish from there. We get, we get it for free. Yeah. Okay. And then this one, use a laser, so we have to travel to the next one, so we get it for free. Do we have to like extract the answer or something? Just the minimum cost? That's kind of weird. This doesn't seem that bad. So yeah, we just shoot the laser. Then we have to go to the next room, come back. Then we shoot with the pistol. We pay the travel time. We get this for free. Should have read this. Okay. So what does this first room look like? We have 3. Okay, well, let's just draw it vertically, I guess. So 1, 1, 1, and then a 2, and then a 1, 1, and then a 2, and then 1, 1, 1, 1, 1, and then a 2. Finally a 1 and then a 2. Okay, so our 1 costs $1. Our 2 costs 3. Our 3 costs $4. And then travel costs $3. Use the pistol to kill 3 monsters and the AWT to kill the boss. Okay, so that would be 3 plus 4. What is 3 plus 4? 7? Plus 3 again, so 10. Move to stage 2, total time is 10. Use the pistol twice and the AWT to kill the boss. Was 16 plus 3, yeah. So now it's 19 plus this, so this costs 19. Use the laser gun, force to move to stage 4. Move to stage 4. Use the pistol once. Then use the AWP to kill the boss. Oh, you don't have to end at the last one, I guess, is important. Yeah, okay. You start at the first room, though? Okay, alright. So the DP is a little bit different. something like that, that's fine. Then you can, after doing that, yeah, you can also, okay, you can go right several times and then come back left again after. Now people are solving it for sure. Yeah, okay. Good. So you can go right several times and then come back, but only for a suffix. Yeah, so we can make like a second DP for doing that sort of thing. Which is simpler, I guess, because you just kill a bunch of people, move to the next room, blah, 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 and then come back. The important thing is for the last room, you're forced to use the AWG. Yeah. You totally have a choice? Okay. Yeah. So what does that look like? So we're gonna need a DP2. Then we need a go-to as well. Just with the position. So this is quite different, actually. Okay, so if dp2 at position is not equal to -1, then dp2 at position best is still this. Return dp2 at position is equal to the best. So now what are my options? I don't really have a choice. So if position is equal to n rooms minus 1, then best equals, oh yeah, I could use the laser, or no, I can't use laser, I have to use the pistol. R1 times n enemies at position plus AWT. but let's R3. Yeah, have to do that, and that's it. Oh, wait a minute. If I'm at the last position, I don't have to pay for the travel time. Was I just up by 3? This isn't right, though. This will still give me the wrong answer. Because there's a case I'm not handling. Too good. Why too good? Shouldn't be answering too good. Should be taking me too much time, not too little. Basically, I just don't need to pay for this last travel time, always. Yeah. Yeah, that's fine, I think. I say 29, the answer is 31. Okay, so we need to draw that out. Why is this happening? 1, 1, 1, 1, 2, 1, 1, 1, 1, 1, 2. 2, 1, 1, 2. R1's equal to $2. R2, R3 is both $4. And then travel time is 1. So I guess I should print what I'm saying. Not very many states. Should be easy to debug. Position 3. So 0, 1, 2, 3. At position 3, free back equals 0. That's equal to 8. How do we do it with 8? R1, R1, R3. 2 plus 2 plus 4. Yeah, sounds good. Free back equals 0. That's equal to 6. We could do 2 and then an R1. Yeah, that's also right. DP at position 2, free back 0, equals 13. So we're saying these are 13 either way. Well, what would it be? It would be like laser, travel, pistol, travel, pistol, AWG, travel, pistol, AWG. So we travel 1, 2, 3, 4, 5 times. We use the laser 1, 2 times. We use the pistol 1, 2, 3, 4 times. Pistol, AWG. Use laser twice. We use the pistol 1, 2, 3, 4, 5 times. 5 times 2. Then we use the AWG 2 times, so 4 times 2. So the correct answer should be 5 plus 8 plus 10 plus 8, which is 16 plus 5, which is 31. Huh. But I'm claiming to be able to do better. Well, this is the suffix, right? So this is 1 plus 6 plus 8. One plus 6 plus 8 is not 13. It is 15. So that's my problem. Why is this 13? Right? It should be, if you get to position 2, you have to do a pistol, then an AWG, then travel, then pistol, AWG. Oh, unless I get to 6. Yeah, so this should not be 13. So DP at 2, 0 should be equal to 15, not 13, I think. So I want position 2. Well, that's 15. On transition 2, it moves to 13. So this is 2 times travel time. That's 2. 2 plus 2 plus, yeah, okay, so it's 2 plus 3 plus 2, or plus 4. Plus 6. That's 8 plus 7. Wait a minute. 8 plus 7 is 13. Why? Why? So we're saying pistol. Okay, you're 6. Oh, yeah. This should be an enemy's plus 1. This should also be an enemy's plus 1. Okay, these are all wrong. Alright, so we still have the wrong solution, but we pass samples. We don't pass samples. Good. Okay, so how do we do better? So now we need this go to. This will be when we need to finish a suffix. Let's get rid of these print statements because they're annoying. Okay, if we're in the last room, we just do this. And that's the answer. Otherwise, if we're not in the last room, we need to kill a bunch of things, then come back. So it's travel time times 2 plus some other stuff. So what options do we have? We can do well, we need to do R1 to kill the boss, plus it's either plus math.min of R1 times n enemies at position plus 1 or R2. You can do one of those two things. Then we travel twice. Then we have to go to the future. So go to at position plus 1. Yeah, okay. If we're at a given position, we could also return the min of go2 at this position +1. It's always possible. I think, yeah. No, we do fix that, okay. That's 31. Sounds fine. I'm not too worried about the runtime actually. Should be fine, I think. Stack trick is going to be an issue though. So time limit, 2 seconds. Yeah, so stack trick's important. Surprised that compiled, to be honest. But that's fine. So that one's 31, this one's 34. Sounds like a submit. This took a lot longer than it should have, though. But oh well. Time limit would be annoying, but fixable, I think.
Problem C got runtime error.
Runtime error? Really? Runtime error? Is it like a max case thing? Wait, how does this even runtime error? Give me a minute. Runtime error. Come on. Position. Free go back. Those are both small. We fill this with -1s. Let's go 0, 0. Oh, can this be 0? No, we have at least 2 rooms. Runtime error? How is it a runtime error? Maybe it's a stack trick thing. Can I just do this real quick? Oh, I have to read them in, don't I? Runtime error. Did I submit the right code? Test case 11 too. What? What could possibly runtime error? I'm incredibly confused at the moment. Well, we can just do this. This will be helpful. At the very least, this will speed things up. A little bit. Yeah, I'm incredibly confused. Wait, that's not right. Hold on a minute. 34, 31. So let's look through this one more time, see if we can figure out what the heck is going on. Otherwise, we'll just submit. We only ever access position. We go to position +1. but the number of rooms is always at least 2. Yeah. So that's fine. To position, this is 10 to the 19, or 10 to the 18. Should be very small. So I don't know why this would be a runtime error. I guess if this fails, then we generate random data.
Wrong answer. A-C or problem C.
Does that mean I did stack trick wrong? Was the stack not big enough still? I don't really understand how that could have gone wrong. Maybe, yeah, that's weird that it looked like that. Huh, darn. That's unfortunate too, because that's, I went from doing well to doing poorly. But I guess it's not the end of the world. I wonder if this is still +6 delta or if it hasn't updated yet. Because just like statistically, it's pretty unlikely I get anything else. Yeah. So it looks like +6. Alright, so let's read the other 2 problems then. I guess who solved them? Kennedy and Raidwush. If tourists can do it, I can do it too. Yeah, okay, so we need to get all of the interesting. Okay, yes, it just hadn't updated, but yeah, it's fine. Huh. Glad to see that Devil's doing this one. Okay, so yeah, I guess maybe like we from the information on the scoreboard, it doesn't really say much about which of these problems is easier, but we think the testers thought that problem D was easier, which means the people who tested it were better at solving D. So D is probably easier. The sample size is very small still, but yeah, I guess it doesn't hurt to read both of these. There's a chance like E is geometry or something I'm good at. Distance matching, oh my goodness. You have an integer k in a tree with n nodes. Let this be the number of edges on the shortest path from U to V. To find the unweighted or undirected weighted complete graph, G is the following. They're defining an okay. Find a perfect matching with total weight k. Yeah, okay. That makes sense. So if you look at a given edge, the number of times some edge is used is rather small. Well, it's not necessarily true. It might be order n times, but its parity is fixed. Like, you can't change the parity of the answer at all. You also might not be able to get up to n squared. Might be too small. For instance, if you have a snowflake, it's going to be about order n, right? It's going to be like 2n-ish. 2n minus 1 or something. Or maybe just n, because it takes, yeah, it'll just be like n minus 1 or something. You have a snowflake, an even snowflake, it's n minus 1. So yeah, so you can't necessarily even make it up to k. But you can decrease it pretty quickly. What's the smallest you can do? If you two-color the tree, I guess you can find the smallest you can do with a DFS. And can you like translate one of those answers, like the smallest into the biggest, slowly? Maybe you can. Seems annoying to implement though. Let's work on D instead. 36 minutes for D. Shrimpy duck. What a name. What a name. Yeah, okay, so we've got a rectangle of like a bunch of points. We've got this big rectangle, and we have a bunch of points in it. Wrong problem. Yeah, because the number of rectangles is up to L to the 4th, so we need to print it under mod. That makes sense. Well, we can divide this thing up into squares, right? So now we have a bunch of squares. Each square has some area, which is just the number of times we want to count it. So the question is, if we pick this square here, how many other squares contain everything? Contain like at least one of each M&M. Interestingly, this grid is only 2000 by 2000. Yeah, so it seems like you can do some sort of like monotonic. You can keep like a monotonic array of like where you have to be for the next one. So you've got some rectangle. It might be helpful to just have the lines drawn in. We'll worry about coordinate compressing at the end, maybe. So then if we're looking at some given height, maybe we like brute force the bottom. Yeah, we're gonna brute force the bottom, then go through each different type of square. Then we have like, as you move over one, what changes? Well, when you add one M&M, I guess you just add an M&M and that's it. So now, what do you do when you're doing your query? You see, like, what's the minimum distance I have to go to the right in order to get all of the M&Ms? That's the interesting part. Like, that's what you're trying to answer for each bottom left corner. Or I guess maybe even easier, we have a series of monotonic chains. Yeah, I guess. You've got a bunch of monotonic chains, and you want to see how many things are above all of them. So it's like the worst thing. What does that even look like? So there's one chain. Next one might be like this. Okay, so we have one monotonic chain. I'm gonna do something else that's like this. So now you have to cover at least one of each thing. It's kind of a weird question to ask, isn't it? Like, what does that even look like? So if this is your bottom left corner, what top right corners are legal? Anything in here? Anything in here? It's also in here. Or it's in here. Maybe I've drawn these backwards. I just rotate my sheet of paper. Yeah, that's good. So now I just want the intersection of a bunch of these things. So I had, the initial problem was find the union, like the monotonic chain problem is like find the union of a bunch of these. Now you want the area of intersection of a bunch of them. But there are updates. The updates make it hard. They are offline. Yeah, I don't know what to say. Don't really know how to do it. Maybe maybe I'll take a quick break, look at the Div 2 problems, or like look at the scoreboard at least. It's kind of the classic 5 problem format. No one's doing it. Oh, let's go Ruben. Plus 100. Will he become blue? Maybe. Ruben's kind of a very well-known cyan, I guess. Cyan / expert. His graph is just hilarious. Look at this. I mean, come on. How can you not feel for the guy? Interestingly, he codes in like Delphi or something weird. Very, very one-off programming language. All right, back to thinking about this. So I guess one thing we can abuse is that the queries aren't arbitrary. We can like choose the order in which we want to do the queries. Like the queries can always go from like higher to lower if we want. Seems like I'm definitely going to have a log somewhere though. Like n squared log n is like the best I can kind of hope for with this solution path. Can you like divide and conquer? So you're going to try to add points. Yeah, add a point of a certain color. That shouldn't be too hard to do. Oh, maybe we can do like small to big. For merging two different colors. It's tricky because you can't like this union and intersection stuff is not just associative. The order that you do it matters, which means it's hard to like move things around in order to make it fast. Yeah, I don't know. I just feel kind of stuck here. Maybe there's a better way of approaching it than thinking about it like this. Do we care about everything I'm keeping track of? Well, we only care about the area, but how the area changes depends on what its shape is. So we kind of do care about all of this. Alright, let's go back to what operations we need to support. We need to add a point of a certain color and query the sum. The like sum of the unions, like union of each color, and then we need the intersection of this. I guess once a square is supported, it will be supported forever. Yeah, that's important. That makes it a lot easier. Yeah. That would be super nice. The issue is moving, like there's not a good way of walking through the grid. If we walk left, then we need to add in all of these points here. If we walk left a second time, we need to add in more points. But then when we walk right, oh, I guess that's not that bad actually, because each point will be added. Like each point gets added or removed order n times. So we don't have to worry about the runtime there. Yeah, okay, so now the real question is, how do we like effectively query candidate positions? Because we can walk without concerning ourselves with the time complexity. We can walk left or right and just not worry about it. But how do we find like how do we say like, yeah, we should be worried about this position here? I guess we could maintain this like this monotonic chain, and then you can do, oof, you need 2D min. 2D min is kind of tough. It's like log squared at best. Tough problem. Yes, that's why it has 9 solves. Yeah, I guess Reedwich isn't even getting it. Kson, it's tricky. Andrew's not getting it. Yeah, it's hard. Alright, I guess not the end of the world. I don't even have a solid idea, so even if like I knew how to do it, I probably wouldn't be able to implement it in 13 minutes. So, okay, well, I guess let's go over the well, yeah, let's read the Div2 problems first. Then we can talk about solutions. Or I guess we'll do context analysis, see what I thought about the problems, and then, yeah, then do solutions to everything. So we have a bunch of strings of lowercase Latin letters. In one operation, you can remove a character from a string, insert it into an arbitrary position in some other string, or possibly the same string. Can you make all n strings equal? Well, all that matters is the counts of each character. So if the counts of each character are all divisible by the number of strings, then you can, otherwise you can't. Very good. Power sequence. So you have a bunch of positive integers. It's a power sequence if there's some integer c. So that for every I, then ai is equal to ci. Given a list of n positive integers, you're allowed to reorder the list, pick a permutation, blah, blah, blah. Or do the following operation any number of times. Pick some index and change this to plus or minus 1. Find the minimum cost to transform this into a power sequence. Oh, okay, that's a cool problem too. I like it. Yeah, that's really clever actually. Let me just think if there's an easier way to come up with this solution than what I'm thinking of. How do you do this case? It's at least 3. Yeah, okay, that's fine. Yeah. Yeah. Very cool. All right, cool. Solution time then. Let's do that. All right, so I really like power sequence. That's a cool problem. Juggling letters, I don't know. It's problem A. I don't really have super high expectations for problem A in a Div2 set. Like, it's interesting enough, I guess. It's not the end of the world. Let's make sure, yeah, OBS is still working. Solid. Let's open whiteboard then. So for problem A, yeah, it should be pretty clear. The idea is that you can shuffle the letters around however you'd like. So all that matters is like the set of letters you have, rather than which strings they're originally in. And if all of the strings are the same, then the first character of all the strings has to be the same. So whatever that first character is has to be a multiple of n, however many times it occurs. So if n is 5 and you have 13 A's, well, every time you place an A, you have to place it in all the strings. So you can subtract, like if n is 5, you can subtract 5 from the number of A's you have. Yeah, so like you've got like 3 strings of length 5 or something, or let's say 3 strings of length 4. Then if you place something, well, you place it in this position, this position, and this position. Maybe you place another character here, like this. So all that matters is like the number of A's has to be a multiple of 3. In this case, it's 6. Yeah, so that's the problem. Or the solution, I guess, to problem A. Div2B is pretty cool. So the idea is you want to make this into a power sequence. The first thing you're going to do is sort it, obviously. But then after you sort it, you have to make these numbers into some power sequence. The thing is, you don't know what this base is supposed to be. So it seems initially like it's really hard. The base might be anything, right? And you might have like an n-squared solution. If you have like if you brute force what this base is, if you make the base something really big, then you have to check for each thing in the array how much you have to change it to get to the right power. So it seems like it would be tricky. But in reality, let's look at how big the base can actually be. So if n is 10 to the 5th, then your numbers will be like, and let's say the base equals 2. your numbers will be 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, etc. all the way up to like 2 to the 10 to the 5th minus 1. Now, this number here is absolutely gigantic, which means this last number is going to contribute a ton to your total. It would be a lot easier if instead you just made 1 to the 0, 1 to the 1, 1 to the 2, etc. Because now your sequence is just a bunch of 1s, and your total is just going to be the sum of all the numbers. So your total is going to be 10 to the 5th times 10 to the 9, worst case. If this number ever gets bigger than this, than like 10 to the 14, that means it's easier just to use all 1s. So we can do a bound on that. The smallest n can possibly be as 3. If n is 3, you have 1, n, and n squared. Or you have like some number, I guess this is your base, which they called c, and then you have c squared. So if c is bigger than like 10 to the 7, then this isn't really a very beneficial thing to have because you pay for it all here. So you can brute force c up to like 10 to the 7. Yeah. But then, yeah, so there's that. And you don't need to brute force c up to 10 to the 7 if n is equal to 4. If n is equal to 4, you only need to brute force c up to like some very small number, like I guess like 10 to the 5th or something. 10 to the 5th is even too big. You could even do like 10 to the 4th. 10 to the 4th to the 4 is like 10 to the 16-ish. So you know you'll way past any reasonable base. So basically you can brute force the base up until the biggest number gets too big. You should watch out for overflows, obviously, but it shouldn't be that bad. And then if you do that, then you like you're able to just naively check what would the cost of making this array be. Yeah, that's the idea. So when n is really small, you might have to check a lot of different candidate c's. But when n is big, you only need to check c's of like once n is equal to 30, if n is greater than or equal to like 30. I guess that's not true. Maybe like 60. Once you greater than 60, you only need to check bases 0 and 1. And then once n is bigger than like 100, you only need to check base 1. So that's the idea. Yeah. I don't have code for it since I didn't compete in the contest or in the Div2 part, but yeah. Okay, so let's look at the Div1 problems now. Cool. Yeah, Div1 A was the same as Div2C. You're given a bunch of numbers, and what you can do for each operation, you can pick some segment, and then you can change every element in the array. You can either add the length of the segment times some multiple, or subtract the length of the segment times some multiple. I guess if the multiple can be negative, you're always just adding times some multiple. So that's the operation. How you do it is pretty straightforward. The idea, I'll just show my code for it since it's so easy. But the idea is that, well, okay, I should explain. So yeah, you've got a bunch of elements. If you pick this array here, and then this array here, you can modify each of the first n-1 elements by any number, right? Because these two differ by 1. So let's say you want to add 1 to this element, then you can like add this number. So this is like 6, so you can add 6 here, and then you can subtract 5 here. That will add 1 to this. If instead of adding 1, you want to add like 10, then you can multiply both of these by 10. So you can add 60, subtract 50. Now you've added 10. That's just 2 operations. So there's a third operation. If we want, we can just do 0. Add 0 to everything. That would be the third operation. The issue is we're missing this last position here. So there are a couple of things we can do. We could choose just this last thing on its own. Now we have a 1, so we can add whatever we want to it. Or what I did was, maybe it's a bit more complicated than it needs to be. I did all of these things, and now I just made all of these equal to 0. So I didn't change any of these, and then I just changed the last one in the same way. So yeah, you can add any number to these in 2 operations, and then you can affect all of the elements like that, just like this. You can actually do this, it doesn't necessarily have to be, they don't have to differ by 1. Any time in which they are co-prime, it's possible to do this. And that's like Bezoot's identity. There was a Wikipedia page that I looked up in the beginning of the contest that shows you how you can do that. Basically, you use extended GCD, but the extended GCD will just end in 1 step in this case because they differ by 1. So yeah, so you can just like kind of hard code what will happen. Cool, that's problem A. Problem B was, yeah, this was, okay, I love game theory games, but this game theory game was kind of lame. It was very transparent what to do, I thought. Yeah, like I'm a big fan of game theory. I definitely want more game theory problems. They're very fun. You feel cool when you've solved them. This one was boring. Yeah. So, well, what was it? So yeah, so you've got a bunch of piles. On a given turn, you take 1 stone from 1 pile, and you just can't have 2 players who take from the same pile 2 turns in a row. Obviously, you want to take the last stone. If you do, you win. And the question is, if both players play optimally, then who wins? So the first thing to notice is, let's say you have one really, really big pile, and you go first. You can just repeatedly take from that pile. So if you've got something that looks like this, you've got like a really, really, really tall pile, and you've got like some other really small stuff, then you know the game is going to end when you take some stone from this and there's nothing else. That's how the game will end. Maybe not you take it, but someone takes from the top pile. And you want to be the one who takes from the top pile. So if you start taking from the top pile and then I take something, some small thing, you take from the top pile again, I take some small thing, then every turn you're the person who's taking from this top pile, which means you can effectively force a win just by doing that. Now, yeah, so how big does it need to be for that to be the case? Well, every turn that you move, you have to take from the top pile, from the biggest pile. Otherwise, it's possible that I will take from the biggest pile, and now I'm the one in this winning state. So every time that I go, you have to sacrifice one of your stones from this big pile, which means the number of stones in this has to be greater than, greater than half of the stones need to be in this big pile. So if this has 4 and this has 3, then after one turn, it has 3 and then this has 2. And eventually we'll get to the case where this has 1 greater than or equal to 1, this has 0. And now you can take this stone and then you're fine. Okay. So that's what happens if there's one pile that has greater than half of the stones. The other case is if there isn't any pile like that. Now in this case, all of the stones will be taken. That's just how it ends up happening. Because whoever would win if all of the stones get taken will play so that all of the stones get taken. And they'll always be able to make sure that happens. The strategy they can use, I think, is just always take from the biggest pile they're allowed to. So I guess I can do a demo of that. Let's say we have something that looks like this. So in this case, there are a total of 11 stones. That means the person who goes first will win. So let's say I go first and I take this, and now maybe you take this stone here. Now I want to find the biggest pile that I'm allowed to take from. Maybe I pick this pile here. Now maybe you try and foil my plan, you take this pile here, I'll take this one here. And eventually, basically, like, you'll have these two piles that are always very close, right? Because you keep taking from the biggest one, and that one isn't bigger than half. So as you shrink, this top pile will reach the height of some other pile. After that happens, these two always differ by at most 1. So when they're tied, someone takes from one, the next turn someone can take from the other. Yeah, so if all the stones get taken, it's just the parity of the total number of stones, and then that's the solution. All right, contest is over. We'll go over problem C as well. I don't know why it's called stoned game, but whatever. Yeah, so this Monster Invaders was a pretty normal DP. I wouldn't say it's bad. but it's like just kind of like a pretty normal Codeforces problem. You should definitely be able to solve it. It's like a normal competitive programming problem. It's just like classic DP sort of thing. So this is the kind of thing where, like, I would say at least it doesn't require really any intelligence to be able to solve. It's just like a matter of having done dynamic programming problems before. I don't know if that's good or bad. It's just kind of like what it is. But yeah. So the idea, or the problem, is that you have a bunch of rooms with a bunch of things you need to kill, a bunch of monsters. And let me like write out how many health points each monster has on each floor. So the first floor, maybe you have like some monsters with health 1 and then a monster with health 2. They, like, you always have a series of monsters that are all just like little tiny guys. And these all have health 1, and then you have a boss that has 2 health. So that's what all the floors look like. But they might have different number of monsters that have 1 health. So maybe you have something that looks like this, and then maybe at the end you've got some really big ones. Like that. So now you have 3 different types of weapons. The first weapon just kills 1 monster. So it's like, yeah, it's like a pistol, I guess. So you shoot your pistol and it does 1 damage to 1 monster. The second one is a laser, which does 1 damage to everyone. So you hurt everyone here by 1 damage. And then the third one is a like a AWT, I think they call it. I don't know what an AWT actually is. Let's look that up. Maybe it's pronounced AUT. Okay, so just like an assault rifle, basically. Huh. Interesting. All right, well, you've got this powerful gun, which kills someone. So you can kill it. You'd only use it on the boss, obviously. But you can use it to shoot the boss, and then you kill the boss in just 1 shot. So it's like a very powerful gun. Now, you also have this other cost for moving. So you've got like some move cost. Yeah, this problem takes a long time to explain, but, and then there's this additional rule, which is in addition to having the costs of using each of these weapons and also having the move cost, if you ever hit this boss character, then you have to move into either the next room or the previous room, if the previous room exists. So yeah, that's a thing. So what's the idea behind it? Well, the strategy you would use is pretty limited. So there aren't that many things you can do. One example of what you might do is you might use a pistol. So I'll do this line here. You might kill this guy with a pistol, and then AWT. If you do it like that, then this is like one way of killing them. Another way might be you might shoot him with a pistol, and then hang on. CF notifications is great, but I still have to fix the after round fluke that it does. So you might shoot it with a pistol, shoot it with another pistol, and then you might move to some other floor, eventually come back, and then shoot it with a pistol again. So that's your second option. And then the third option is you might shoot this whole group with a laser. Then you have to go to a different floor. Eventually you'll come back, and then you shoot this with a pistol. So those are the only 3 ways of killing some floor. And the benefit here is that this one, you don't have to move in order to do. So if your movement cost is really expensive, this is probably a good thing to use. But if you have 2 floors in a row that both have a lot of things, then the laser is, it's probably good to use a laser, move, use the laser again, go back, shoot him with a pistol, go back, shoot him with a pistol. Yeah, so there's that. The one other thing to notice is that it's possible that you have some case, so let's say these are the rooms like this. What you might do is you might like use this with like just pistols and then an AWT, and then you might use this one with like a laser, right? Eventually you'll come back here, and then you might go forward again in order to keep continuing through these rooms. So in this case, you need to keep track of the fact that you can go back for free, because in this example, what you could do is when you enter the room for the first time, you could use the laser. Then this is your go back part, like you move to some other room after you hit the boss. And then when you come back into this room, then you can just snipe the boss with your pistol and then you're good. So you could do something that looks like this. This part is important to keep in mind because, yeah, like I said, you don't have to pay the additional 2 travel cost because you can share the travel cost with the additional movement that you need from the previous room. Okay, yeah. So then there's one other thing to keep in mind, which is you don't have to finish at the end position. So it's not always cross once or cross 3 times. You might cross twice, actually. That looks like this. You might cross here and then come back here and then stay here. Or you might have another room here. You might cross this again and then come back. And then you might do this for any suffix. But the idea is you don't have to go to the finish, so you don't have to pay this travel cost. So this part is easy to calculate with the DP. The DP for a certain value is either you have to kill all of these things with pistol shots and then go to the next room and then come back and then you kill it with another pistol shot, or use a laser and then use a pistol shot after. Wait a minute, am I gonna get hacked? Uh-oh. Uh-oh. I could be in trouble here. Let's look. Were there hacks on problem C system tests? Okay, looks like most people are passing. And no one has hacks, really. I think I'm missing a case here. Yeah, I'm pretty sure I'm missing a case. You might want to pay the pistol plus the AWT, right? No, you never want to do pistol. No, I'm fine. You don't want to do pistol plus the AWT because you could just do the laser plus the AW, or the laser plus the pistol. Yeah, okay. All right. I was worried there for a minute. Sorry, back to solutions. Yeah, so there are 2 ways of doing this. Either you do a bunch of pistols and then 2 pistols for this last character, or you do a laser for a bunch of things and then a pistol for the last character. Those are the only 2. If you know you're gonna come back, these are the 2 best ways of doing it. The reason for that is that the price of the pistol is less than the price of the laser, which is less than the price of the AWT. Okay, cool. That's problem C. I don't know how to do problems D or E. I don't really even have a strong enough idea on D for it to be helpful, so I won't even try and explain it. But yeah, cool. So those are the solutions to the problems that I know how to do. Hope you enjoyed the contest, and I don't know, system test is going to be a while, so I won't wait for it to finish because it's going to take a bit. So yeah, thank you for watching, everybody. I hope you have a great day, and I hope the round was good for you. That's all. Goodbye.